Alrighty, so that's all we need to know about arithmetic sequences, and we'll do some more practice before the test. We're going to finish out our arithmetic day looking at arithmetic series. So remember the beginning of the video, I talked about sequence versus series. A sequence is just a list of numbers versus a series is when we're adding up all the numbers in that sequence. So this is where we're going to use those S sub n formulas. And again, it just depends on what information we're given as to which one we're going to use, but you're going to be given those on your formula sheet. You're going to be given those on your test. So you can always refer back to those for extra help. You don't have to have those memorized. Okay, so for series, find the value of each arithmetic series. In other words, if we add up all of our terms, what are we going to get? So a sub 1 equals 8, a sub n equals 50, but then they go around and tell us that n equals 14. So we're looking at a 14-term sequence. First term is 8, and the last term is 50. So that means I can use the formula S sub n equals n over 2 times a sub 1 plus a sub n, because they just gave me all of the info straight out for that formula. So 14 divided by 2 times our first term 8 plus our last term 50. So 14 divided by 2 gives me 7, 8 plus 50, 58. Even if you're plugging this into the calculator, I would still simplify each piece before you type it in. If you're dealing with fractions and parentheses, especially if you're using a TI calculator to check your math, it is really easy to leave off a parenthesis and you wouldn't necessarily know it if you're running through your problems quickly. So we go through and we multiply 7 times 58, and that gives us 406. So if we added together every single term going from 8 up to 50, then we would get the sum 406. Now notice they didn't even tell me what the common difference was, but it's almost kind of averaging those differences out to figure out what everything's going to end up coming together to be. Kind of like we found the arithmetic means and added them all up all in one step. Alrighty, number 13, they gave us a sub 1, they gave us d, and they gave us n. So for this, again, the formula we just used in number 12 probably wouldn't work too well for us, so let's use the other one. So S sub n equals n over 2. They start the same way, but now they get a little bit more complicated. So 2 times our first term, a sub 1, plus n minus 1 times d. So it kind of looks like the formula that we found that we used for, an individual term, but it has the extra n divided by 2 out in front, plus multiplying that first term times 2. And again, this is not something that you'll ever need to derive. Just know that, what types of info you're given goes for which variables, and then which variables do you see in the correct equation. So let's just plug in. So S sub n, we're looking at our n is 7, so 7 divided by 2, times 2 times our a, which is 6, plus our n was 7, so 7 minus 1, and our common difference was negative 5. This is where order of operations is going to be very important. Simplify as much as you can before you start plugging anything into the calculator. So I'm going to leave the 7 over 2 for the moment. 2 times 6, 12, plus, this is really a 6, and 6 times negative 5 is actually going to be a negative 30. So this is really 7 halves times a negative 18. And I don't even need to use the calculator now, because divide by 2 simplifies out to a 9, and 7 times negative 9 is going to give me a negative 63. Now you're thinking, well, how can the sum of all of my terms be negative? Well, keep in mind, your common difference is a negative 5. So that means starting from 6, you subtract a 5 from every term to get the next one. And so your values are actually, you're going to have a lot more negative values than you're going to have positive values. Hence, our sum is negative. Okay, number 14. They gave us the same kind of info, almost. So D equals negative 3, N equals 21, A sub N equals negative 64. So again, we've got to do a little bit of legwork here just to figure out what we're looking at, because either one of the formulas, either the one we used in 12 or the one we used in 13, they all require us to know that first term. So let's figure out what that first term is. So let's go back to our a sub n formula. So a sub n equals a sub 1 plus n minus 1 times d. If we're trying to solve for a sub 1, this would let us do that. We know a sub n is negative 64. We don't know our first term, but we do know our n is 21. So 21, sorry, my brain's jumping ahead because 21 minus 1 gives us 20. And our common difference is negative 3. Only one variable left, let's solve for it. So negative 64 equals a sub 1 plus 20 times negative 3. So that's really going to give us a negative 60. Add 60 to both sides. A sub 1 equals negative 4. And now we have enough info that we could use actually either one of our formulas. I'm going to go ahead and use the same formula I did in number 12. So S sub n equals n over 2 times a1 plus an, because now I have both of them. So n is 21, a sub 1, negative 4, plus a sub n, negative 64, aka negative 68. Again, the 2 cancels out, which is nice for me, but you could always plug it in the calculator. So that's going to be a negative 34. And 21 times negative 34, which you're going to want to plug in anyways, most likely negative 714. Alrighty, last thing to look at is really just a quick notation. Now, there are a couple different ways to do this, but I'll be honest, the way that you can do this on a TI calculator is, pretty involved with the number of steps. So this is the sort of thing that you're really just going to want to use on a Desmos calculator. And so what you can do for the Desmos calculator is, if you open up the keyboard, click on MISC, the miscellaneous functions, you should see something that looks like what I've got in the box. Now, this is called a summation. Well, that's a series. A summation is just kind of a shorthand notation of saying, let's just add up all the terms in this sequence. And it's just kind of a more succinct way of saying that in mathematical kind of terms or mathematical symbols. So you can absolutely calculate that. And I would definitely suggest doing that through Desmos. So again, hit the little keyboard button, go to functions and go under the miscellaneous. And you should see that biggie, and it'll just let you type in whatever you need in your spaces. But basically, this is, again, shorthand notation for saying this is our formula for their terms, and I want you to add them all up from this term to this term. So in number 15, just to show you what this means kind of straight out, this is saying number 15, I want to add up all my terms from the first term, n equals 1, to the third term, 3 up at the end of that fancy E. And my equation for each term is 3 minus 4n. So that means I've got 3 terms to work with. My first term, I'm going to plug in the n equals 1. So that'll be 3 minus 4 times 1. And I'm going to add that up with my second term, plug in n equals 2. So 3 minus 4 times 2. And then n equals 3, the last term, plug in a 3. Okay, well, let's see. 3 minus 4 times 1, 3 minus 3 is, or 3 minus 4 is a negative 1. Negative 4 times 2 is negative 8, so that would give me a negative 5. And let's see, negative 4 times 3 is 12. 3 minus 12 would give me a negative 9. And so if I add those all up, I get a negative 15. However, use that trick on the Desmos calculator. So again, on Desmos, go to your keyboard, so that button, then hit Functions, then go to Miscellaneous, and look for that fancy E. When you hit that in your kind of line where you can type things in, you're going to have a space down below and a space above, and then you can type stuff afterwards. Type it in exactly the way it looks on your paper. And if you do that with number 16, try it out on Desmos, you should actually end up with the number 748. So Now that you're done with the video, go try that on Desmos and see how it works. Make sure you can get the same answers for 15 and 16. And I'll find an extra video as well that I'll post with how you can do summations on a TI calculator if you would like to see how that works. As always, let me know if you have any questions.